SMAC that includes SYNC phase, RTS phase, CTS phase. SMAC approaches: message passing approach, network allocation vector approach, and virtual cluster approach. SMAC stands for Sensor MAC. The SMAC, that is the Sensor MAC protocol, provides mechanism to avoid idle listening, collision, and overhearing. SMAC adopts a periodic wake-up scheme with virtual cluster features as shown in the figure. Basically, a network is formed as a flat single-hop topology, and SMAC utilizes only one frequency channel for communication. The listen period of SMAC can be used to receive and transmit packet. The listen period is fixed at 115 milliseconds, and the wake-up period can be taken up to hundreds of milliseconds. Thus, the sleep period is adjustable. Within a cluster, all the nodes are synchronized such that all the nodes can wake up at the same time. A node's X listener period is subdivided into three phases. They are SYNC phase, RTS phase, CTS phase. The first phase, which is the SYNC phase. Node X accepts sync packet from its neighbors. In these packets, the neighbors describe their own schedule and X stores their schedule in a table. This is called a schedule table. Node X's sync phase is subdivided into time slot and its neighbors contained according to CSMA scheme with additional backoff. That is, each neighbor Y, let us say Y, wishing to transmit a sync packet picks one of the time slot randomly and starts to transmit if no signal was received in any of the previous slot. In the other case, Y goes back into sleep mode, that is the neighbor node, and waits for X's next wake up. If the other direction, since X knows a neighbor Y's schedule, X can wake up at appropriate time and send its own sync packet to Y in a broadcast mode. It is not required that X broadcasts a schedule in every of Y's wake-up period. However, for reason of time synchronization and to allow new nodes to learn their local network topology, X should send a sync packet periodically. The occurring period is called synchronization period. RTS phase. RTS stands for request to send. Node X listens for request to send packets from neighboring nodes. In SMAC, that is Sensor MAC, the RTS CTS handshake is used to reduce collision for data packet due to hidden terminal situation. CTS phase. CTS stands for clear to send phase. Node X transmit a CTS packet if an RTS packet was received in the previous phase. After this, the packet exchange continues, extending into X's nominal sleep time. SMAC approaches. There are three approaches, namely Network Allocation Vector NAV approach, Message Passing approach, and Virtual Cluster approach. Network Allocation Vector approach. In general, when competing for a medium, the node uses the RTS-CTS handshake, including the virtual carrier sense mechanism, whereby a node maintains a NAV, that is Network Allocation Vector variable. The NAV mechanism can be readily used to switch off the node during ongoing transmission to avoid overhearing. Virtual cluster approach. The Sensor MAC protocol allows neighboring nodes to agree on the same schedule and to create virtual clusters. The clustering structure refers solely to exchange of schedules. The transfer of data packet is not influenced by virtual clustering. The SMAC protocol proceeds as follows to form the virtual cluster. A node X newly switched on listens for a time of at least the synchronization period. If X receives any sync packet from a neighbor, it adopts the announced schedule and broadcasts it in one of its neighborhood's next listen periods. In the other case, node X picks a schedule and broadcasts it. If X receives another node's schedule during the broadcast period, packet contention period, it drops its own schedule and follows the other one. It might also happen that the node X receives a different schedule after it already has chosen one. For example, because of bit error destroyed previous sync packets. If node X already knows about the existence of neighbors who adopted its own schedule, it keeps its schedule and in the future has to transmit its sync and data packets according to both schedules. On the other hand, if X has no neighbor sharing its schedule, it drops its own and adopts the other one. Since there's always a chance to receive sync packets in error, node X periodically listens for a whole synchronization period to relearn its neighborhood. This makes the virtual cluster formation fairly robust. Message passing approach. SYNCH also adopts a message passing approach as shown in the figure, where a message is larger data item meaningful to the application. A network processing usually requires the aggregating node to receive a message completely. On the other hand, on wireless media, it is advisable to break a longer packet into several shorter ones. SYNCH includes a fragmentation scheme working as follows. A series of fragments is transmitted with only one RTS-CTS exchange between the transmitting node A and receiving node B. After each fragment, B has to answer with an acknowledgement packet. All the packet that includes data, acknowledgement, RTS, CTS have a duration field and a neighboring node C is required to set its NAV field accordingly. In SMAC, the duration field of all packet carries the remaining length of the whole transaction, including all fragments and their acknowledgements. Therefore, the whole message should be passed at once. In one fragment needs to be transmitted, the remaining duration is incremented by the length of the data plus acknowledgement packet, and the medium is reserved for its prolonged time. However, there is a problem of how non-participating node shall learn about the elongation of the transaction when he has only heard the initial RTS or CTS packet.